Assalamu alaikum everyone. How are you all? Hope you all are doing good. Today, we're gonna discuss about embedded system and its components, characteristics, constraints, classifications, advantages, limitations, applications, scope, and many more. So, what do you think embedded system is? Let's focus on its name first. It is based on two words. 1. Embedded. 2. System. Embedded means something that is attached to another thing. And a system is an arrangement in which all its units assembled work together according to a set of rules. It can also be defined as a way of working, organizing or doing one or more tasks according to a fixed plan. For example, watch is a time displaying system. So, watch is a system which is showing the time, so its component follows set of rules to show the time. So, we get to know that embedded systems are a combination of software and hardware, where software is usually known as a firmware that is embedded into an hardware. Embedded system is a microcontroller and a microprocessor-based system which is designed to perform specific tasks in a given amount of time. For example, fire alarm is an embedded system. It will sense only smoke. You know what? The embedded system was first used in 1960, for developing Apollo guidance system by Charles Stack Trapper at MIT. Embedded system is based on three components. 1. Hardware. 2. Software. 3. Real-time operating system, RTOS. Hardware. An embedded system uses a hardware platform to perform the operation. Hardware of the embedded system is assembled with a microprocessor/microcontroller. It has the elements such as input and output interfaces, memory, user interface and the display unit. Here's a block diagram of hardware components of embedded system. It contains 1. Power supply and oscillator circuit, which is essential for the embedded system. Most of the embedded systems need the pi-volt power supply. Oscillator circuit is used to pressure the harmonics and synchronization in embedded system. 2. Input devices and input driver circuits. The input gets from the physical devices like transducer circuit, keypad, touch screen, etc. 3. Processors. Processors are the heart of embedded system. The various types of processors we used are 8, 16, 32, and 64-bit processors. 4. Timers. They are used to provide accurate delay on the basis of application requirement. Generally, most of the timers used in the embedded system are timer 0 and timer 1, each are of 16 bits and acts like both timers and counters. 5. Interrupt controllers. It multiplexes a number of possible interrupt sources on the platform for presentation to the processor. The interrupt controller in the embedded system must be configured to prioritize and route interrupts from devices within the SoC, system on a chip, and externally attached devices. 6. Program memory, ROM, and data memory, RAM. Program memory, ROM, is used for permanent saving program being executed, while data memory, RAM, is used for temporarily storing and keeping intermediate results and variables. 7. Serial communication ports. It can be used for inter-processor communication within a system, or for a communication with different parts of system. The serial ports provides the physical connection between the equipment, but a communication protocol has to use to ensure a reliable, error-free data path. 8. Parallel ports. They are used to transfer data, parallelly. 8 bits of data transmitted at a time in parallel port, and it is used to connect devices with high bandwidth. 9. Output devices and output driver circuits. Output devices shows or gives the output like LED, LCD, and other communication systems. 10. System Application Specific Circuits, SASC. It is used for improving speed and reliability. It has been to do one purpose, or do a specific task. It can also be miniaturized and consume less power. Now, moving further on components. Software is the second component of embedded system. The software of an embedded system is written to execute a particular function. It is normally written in a high-level setup and then compiled to offer code that can be stuck with in a non-volatile memory in the hardware. In other words, it has main application software which may perform concurrently the series of tasks or multiple tasks. Real-time operating system is the third component of embedded system. It is a system which is essential to finish the task and send its service on time. Simply, we can say that RTOS defines the way the system works, which supervises the application software and sets the rule for during the execution of the application program. It is also responsible for managing the different hardware resources of a personal computer and also host applications which run on the PC. Note: a small-scale embedded system may not need RTOS. Do you know? In 1960, Wind River released VxWorks. This was initially available for 8-bit processors, but was quickly implemented on 16-bit and 32-bit devices, as they become more popular. Now, let's see the most important part of embedded system, that is its working. Every embedded computing device, may it be your computer or mobile, have some inputs and corresponding outputs. Here's an example of how an embedded system works. It takes the analog or digital input from the user, like push-button switch, keypad, sensor, and touch screen. Then it processes the given input. Processing may be calculation and conversion. For example, an ADC, analog to digital converter, converts a sensor analog input to digital output. After converting the analog value to digital output, you need to control using output devices. For example, motor, LCD, and touchscreen. Now let me tell you some characteristics of embedded system. Unlike some general computer systems, embedded systems work only for a particular function on a time-bound manner. For instance, a washing machine cannot multitask like a laptop. In this regard, here are some unique characteristics of an embedded system. 1. Single function. An embedded system usually performs a specialized operation and does the same repeatedly. For example, a pager always functions as a pager. 2. Tightly constrained. All computing systems have constraints on design metrics. Design metrics is a measure of an implementation's features such as its cost, size, power, and performance. It must be of a size to fit on single chip, must be fast enough to process data in real time and consume minimum power to extend battery life. 3. Reactive and real-time. Many embedded systems must continually react to changes in the system's environment and must compute certain results in real time without any delay. 4. Microprocessor-based. It must be microprocessor or microcontroller-based. 5. Connected, peripherals. It must have connected peripherals to connect input and output devices. 6. Memory. It must have a memory, as its software usually embeds in ROM. It does not need any secondary memories in the computer. 7. Hardware and software systems. Software is used for more features and flexibility. Hardware is used for performance and security. Here's a query for you. You guys know when did the first microcontroller developed? It was developed in 1971 by Texas Instruments. Along with those characteristics, embedded system have some constraints too. These are the three main constraints of embedded system. 1. Convenience of system memory. Based on available system memory, we can have the length of the program which we store in our hardware. In hardware, we can have microprocessor, microcontroller, and along with that there's a finite amount of memory. If you have larger length of program, in that case you need to have more memory. 2. Convenience of processor speed. If we have higher processor speed, then we can have faster execution of tasks, so processor speed also defines execution, whether it is faster or slower. So, that is also very essential constraint. 3. The need limit to power dissipation. When we design embedded system, and that time we will be using battery, and that battery is having fixed amount of charge. So, If power dissipation is higher, then your system will drain power faster and you cannot utilize your embedded system for a longer duration. Like, we have mobile phone. If your mobile phone is getting discharged in half an hour, in that case you cannot utilize that for entire day. So, power dissipation is also essential constraint when we design embedded system. When the embedded system runs constantly, there is a necessity to limit power dissipation for actions like run, stop and wake up. After all those characteristics and constraints, I am going to tell you about classifications of embedded system. On the basis of performance of the microcontroller, embedded system classifies into the following three categories. 1. Small-scale embedded system. It consists of single 8-bit or 16-bit microcontroller, and little hardware and software complexity due to small size of microcontrollers. They may even have been battery operated and also needed to limit the power dissipation when system is running continuously. It requires small memory as it deals with small amount of data and also easy to program using assembly language and C programming language. For example, robotic arm controller, electronic toys, automatic coffee vending machine, thermometer, etc. 2. Medium-scale embedded system. It consists of single or few 16-bit or 32-bit microcontrollers or digital signal processors, DSP. Along with microcontrollers, you may also need application-specific OS. In these types of embedded system, software and hardware complexity is present and offers more speed than small-scale embedded system. For example, routers, ATMs, music systems, pagers, etc. 3. Sophisticated embedded system. This type of embedded system consists of 32-bit or 62-bit microcontrollers and multi-core processors with enormous hardware and software complexities. Power consumption is the highest among rest types of embedded systems and requires very high memory power. Speed is a major concern of this type of embedded system. Some applications, like satellite systems, also involve real-time operating system, RTOS. For example, mobile systems, washing machines, digital watches, LAN cards, multimedia systems, etc. Here's something for you. You know? The first embedded Linux system was appeared in late 1990, by Linus Torvalds and other community members. So today we discussed about embedded system and its components, working, characteristics, etc. etc. Now, let's have a look at its advantages. 1. Easy to manage. Embedded system meant for general use, are easy to manage. 2. Fast performance. The performance of an embedded system depends on various factors. Developers must fulfill non-functional requirements like execution time, energy consumption, and memory capacity to optimize a system's performance. 3. Small in size. Compared to traditional computers, embedded systems are smaller, meaning they take up little space and are easily portable. Due to their small size, embedded systems require less power compared to large systems and loads faster, as the system has few elements to manage. 4. Less power consumption. They also have low power consumption, which helps reduce energy costs for the overall system. 5. Low cost. It can be developed at lower cost. Hence, it has become very popular among enthusiasts and end users. 6. Enhanced performance. Embedded system offers advanced performance, higher reliability and higher efficiency. Along with advantages, every system has some limitations too. Following are the limitations of embedded system. 1. Difficult to upgrade. With respect to time, technology is getting upgrade, but in embedded system, we use as fixed microcontroller, so it is very difficult to upgrade with respect to time. 2. Reset setting. If any problem occurs, then you need to reset the setting. 3. Troubleshooting is very difficult, as it is complex system. Once we designed it, we fabricated on PCB, and if any problem is arising, in that case, it will be difficult to have troubleshooting. 4. Limited hardware. Because these systems are made for specific tasks, hardwares of these systems are limited. 5. Bad data transferring. Transfer of data from one system to another is also quite problematic. 6. Hard to maintain. These embedded systems are hard to maintain. It is also difficult to take the backup of embedded files. 7. Limited resources. They also have limited resource or memory, due to making it for specific task. Now, I am gonna tell you the applications of embedded system. There are many applications of embedded system in many fields. Some of them are 1. Automobiles. Like, motor control, cruise control, body safety, engine safety, robotics in an assembly line, car multimedia, car entertainment, e-com access, mobiles, etc. 2. Telecommunications. Like, networking, mobile computing, wireless communications, etc. 3. Smart cards. Like banking, telephone and security systems, etc. 4. Satellites and missiles. Like, defense, communication, aerospace, etc. 5. Computer networking. Like, image processing, networking systems, printers, network cards, monitors, displays and etc. 6. Digital consumer electronics. Like, set-top boxes, DVDs, high-definition TVs, digital cameras, and etc. Hey! I've got 2 amazing facts for you guys. 1. Embedded system was first used in automobiles in 1968. Volkswagen 1600 used a microprocessor to control its electronic fuel injection system. And 2. Embedded system was first used in technology in 1965. Autonetics developed the D-17B, the computer used in Minuteman missile guidance system. Finally, all I want to say is, embedded system is the future. Every industry needs some artificial intelligence into it, and artificial intelligence can be given by embedded systems only. No electronic product is without embedded systems in the market. The advent of artificial intelligence will boost the use of embedded systems. Hence, the future of embedded system technology is bright. Also, a lot of career opportunities are also available in embedded systems. Some of them are 1. Embedded software engineer, firmware. 2. System software engineer, kernel and partos. C. Here's an article saying that the embedded market reached $140 billion in 2013. And analysts are projecting an embedded system market longer than $40 billion by 2030. Well, that is all I have for today. We discussed about embedded system, and its components, characteristics, workings, and applications. We also talked about its characteristics and limitations. I am pretty sure you guys enjoyed it. Thank you very much guys, for your valuable presence and attention. Allah Hafiz.